Okay, moving on to other operations. Dividing decimals. Let's stick with those same 0.02 and 0.135. 0.02 divided by 0.135. Or we could also think of that as a fraction, 0.02 over 0.135. Now, I don't know my 0.135 times tables, just like I don't know my 0.02 times tables. But I can't come up with 135 times tables. So how do I make this a whole number of 135? If I'm going to do long division, I want this to be 135. Well, I have to multiply by 1,000, right? That's 135 thousandths. So 1, 2, 3, there's times 1,000. 1, 2, 3, that's times 1,000. So the decimal place is over here. I need a 0 as a placeholder here. It's 20 divided by 135. Now, 135 is bigger than 20, right? That's not going to be a whole number. It's less than 1. But I could multiply by another 10. Now, up here I just added the 0. Down here I left it as times 10, right? I guess if we're being precise here. 20 times 10 is 200. 135 times 10, 135 times 10. Because I don't want 1,350. That's going to be bigger than 200. I just want 135 into 200. 135 times 1 is 135. So, let's see, 65. Smaller than 135. But that's a remainder. I don't want a remainder. So let's multiply by 10 again. So now instead of 200, that's 2,000. And 10 and 10 is that's 100. So now I've got 2,000. Okay, so now I can bring down another 0. 135 into 650. Is that 5? No, I think it's only 4. So 400, 5, 20, 30, 40. 540. That gives me 110. I still have a remainder. So let's multiply by another 10. 1, 2, 3, 4 zeros. 1, 2, 3. Get another 0 there to bring down. All right, 135 into 1100. I'm guessing that's 7. Let's see, 135 times 7. 945. Yeah, if I add another 135 to that, I think we're going to go over. No, 1080 is less than 1100. So 7 was too little. I actually need 8 135s. That's going to give me 1080. And 100 minus 80 is 20. This is looking familiar. If I add another multiple of 10, I'm back at 135 into 200, which is where I started. So now it's just going to go 148, 148, and so on. The question is, I had 0.02 divided by 0.135. I see my pattern, but where does the decimal place go? Well, so far the decimal place is here, right? I kept multiplying by 10, so this wasn't 0.02, it was 20. Then it wasn't 20, it was 200. Then it was 2,000. Then it was 20,000, and then 2 million, or 200,000. Eventually 2 million. Divided by 135, and divided by all these zeros. Right? So once I stop here, let's say I stop at 148, I'm then dividing by 1, 2, 3, 4 tens. 1, 2, 3, 4 tens. Right? Is that right? I'm sorry, the decimal place is here. 1, 2, 3, 4 tens. Because this was 1, 2, 3, 4 tens there, right? In other words, if we started over with my 20 over 135, the decimal place was here, and I kept shifting it to the right to get a bigger and bigger dividend so that 135 could go in as a whole number. But at the end, I had to shift it back. So instead of shifting it over and back, we just leave it here. And we get our 1 at as many zeros as we want. Slide the decimal over, slide it back. 148, and then it's just going to repeat. So there's my answer, 0.148 repeating. Clearly very different from 135 divided by 2, right? 0.135 divided by 0.02. This only has 2 numbers after the decimal. So I only have to multiply by 2 tens to get a whole number divisor. 0.135 times 100, 10, 100. In other words, if I start with this, I multiply 1 by 100. Sorry, the 0.02 times 100, so it's regular 2. I multiply by 0.135 times 100. That gives me 13.5. Then I can go ahead. 2 doesn't go into 1. 2 times 6 is 12. Bring down the 5. 2 times 7 is 14. Tack on as many zeros as I want. Bring the 0 down. 2 times 5 is 10. Oh, I didn't need all those zeros because I don't have a remainder anymore. So 6.75. Very different answer from the reciprocal problem, right? 0.135 over 0.02 is the reciprocal of 0.02 over 0.135, right? Just like when you subtract 5 minus 3 versus 2 minus 5, sorry, versus 3 minus 5, we get the additive inverse if we switch the order in subtraction. We get the multiplicative inverse if we switch the order in division. So that's why I have to pay attention to the order when we're dividing. Whereas if we turn it into multiplication, we don't have to stress about that. Just like if we turn this into addition, we don't have to worry about the order. We could have said 0.02 times 1 over 0.135 if we wanted to think about it that way.